autumn of 1951. Somewhere over the vast expanses of North Korea, in the area of the Yalu River, an aerial battle is unfolding. Here, in a narrow strip of airspace that American pilots have nicknamed the MiG-Alli, the fate of the first jet-air confrontation in history is being decided. Two of the world's greatest aviation powers came face to face in the skies of Korea. Soviet pilot Senior Lieutenant Igor Semenov leads his MiG-15 on a combat mission. His task is simple: to protect North Korean positions from American bombers. Soviet pilots are not officially involved in the war. They fly without identification marks, without documents. Even their surnames have been replaced with fictitious names. Moscow categorically denies the presence of its pilots in Korea. This is a ghost war, a secret war where every flight can be the last, and the feat will remain unknown to the world. Semenov is confident in his car. The MiG-15 is the brainchild of a Soviet design genius. This aircraft impresses with its characteristics. He can climb to an altitude of 15,000 meters, where American fighters are suffocating in thin air. Its rate of climb is phenomenal. Its armament, 323 and 37mm cannons, is capable of blowing apart any enemy aircraft in one short burst. The Americans were afraid of this car. Their straight-winged fighters, such as the Lockheed F-80 and Republic F-84, were virtually defenseless against MiGs. But in December of 1950, a new enemy appeared in the skies over Korea: North American F-86 Sabres, a swept-wing fighter designed specifically to combat the MiG-15. The Americans hastily deployed 3 squadrons of these aircraft to the Far East as soon as it became clear that the old fighters could not cope with the Soviet jets. Semenov has already met Sabres several times in aerial battles. In all respects, the MiG was superior to the American fighter. The MiG climbed higher, accelerated faster, and had a better climb rate. Soviet engineers could be proud of their brainchild, and yet something was wrong. At a briefing this morning, the regimental commander returned to the strange problem again. In recent weeks, the losses of Soviet pilots have increased. Moreover, it was not only young, inexperienced pilots who died, who were sent to replace veterans. The asses of the Great Patriotic War, people who went through the entire war, shot down dozens of fascist planes, also fell. Something has changed in the tactics of the Americans. They learned how to hit MiGs from distances at which the Soviet pilots did not even have time to open fire. Semenov leads his foursome at an altitude of 10,000 meters. The ravine-ridden land of North Korea stretches below. Somewhere out there, hiding in the valleys, American fighter jets are moving. This is a favorite tactic of Sabres: to enter from below, take advantage of speed at low altitudes, attack and go down, where the MiGs lose their advantages. And here they are, 4 silver dots at the bottom and on the right. Sabres. Semenov gives a command to his wingmen, and both MiGs go into a dive. Altitude gives them energy, and speed increases. The Americans are spotted. They can't leave. The classic dogfight is about to begin. But the American pilots are not trying to leave. They turn to meet the attack. Is this courage or madness? Counter-combat at high speeds requires iron nerves and absolute precision. Now everything will be decided in fractions of a second. The distance is closing at an incredible rate. 2,000 meters, 1,800, 1,500. Semenov feels every muscle in his body tense. The ASP-1 Insight is a simple gyroscopic system developed back in the late 30s. The pilot must estimate the distance to the target himself, enter the data himself, calculate the lead himself. At these speeds, it requires years of experience and an impeccable eye. 1,200 meters. Semenov catches an American fighter in the crosshair. A little more, and he will open fire. His 37mm cannon will destroy the Sabre in one burst. One more second, and suddenly there was a flash under the wing of an American fighter jet. Tracers. But that's impossible. The distance is still more than 1,000 meters. At this distance, the probability of hitting is negligible. Soviet pilots rarely open fire from more than 500 or 600 meters away. And the Americans, with their 12.7mm rifle machine guns, have to get even closer to cause real damage. But the tracers are heading straight for him. Semenov instinctively throws a MiG into a barrel, moving away from the line of fire. The moment has passed. An American fighter jet zips past, disappearing somewhere below. And Semenov's wingman is shouting on the radio that his car was hit. It's not fatal, but there is damage. They will have to withdraw from the battle. In the evening, in the officers' mess, Semenov meets his old friend, Captain Vasily Novikov. Novikov poured himself a cup of tea and sank wearily into a chair. His face is tired and confused. "Igor, I almost stayed there today," he says quietly. "The Sabre came in my tail. I went into a turn. I did everything right. The MiG turns better at altitude. I had a breakaway. But this American was holding on to me like a leash. And he shot from a distance of more than a kilometer. And he did. I have 3 holes in my wing. They're not the only ones who have faced this problem. All Soviet squadrons in Korea report the same phenomenon. Americans have learned to shoot accurately from incredible distances. Their fire has become deadly effective. Previously, Soviet pilots could afford to get close and engage in close-range maneuvering combat, where the advantages of the MiG were fully manifested. Now it is not possible to do this. Sabres open fire early, and that fire hits the target. But why? What has changed? The American pilots haven't gotten any better at shooting in a few months. Maybe it's about learning? But Soviet pilots underwent no less rigorous training. Many of them are veterans of the Great Patriotic War, Assyrians with dozens of downplanes. They know aerial combat like no one else in the world. Rumors are beginning to spread throughout the Soviet aviation units. Someone says that the Americans have a secret weapon. Someone suggests that Sabres are equipped with a new type of ammunition, homing bullets or missiles. There's even a version that the Americans use some kind of beam that directs fire at the target. Moscow is worried. Comrade Stalin is personally interested in the situation in Korea. MiG losses are increasing. This is unacceptable. The Soviet Union cannot afford to lose this confrontation. The Korean War is a test of the forces of 2 systems, 2 ideologies, 2 worlds. And in the air war, Soviet aviation should dominate. A directive is coming from Moscow. Capture the Sabre. At any cost. We need an intact aircraft that can be studied, disassembled, and understood to be its secret. Soviet intelligence is becoming more active. Agents are listening to the radio conversations of American pilots. The prisoners are being interrogated. They collect the wreckage of downed planes. But it takes a whole Sabre. The first capture attempt ended in failure and became a real disgrace for Soviet aviation. One of the Soviet pilots was ordered to ram the damaged Sabre, forcing it to land in communist-controlled territory. The plan was audacious and dangerous. The pilot had to get close to the American fighter, hit it with his propeller on the rudders, deprive the enemy of the opportunity to maneuver, and then, using the superiority in altitude, force the American to land in North Korea or Manchuria. But the American pilot turned out to be more cunning. Seeing that the Soviet MiG was trying to tail him in an unusual way, he sharply slowed down. A Soviet fighter jet flew by. The American took advantage of the moment and disappeared, reaching his positions. Moscow was furious. The unsuccessful pilot was severely punished. Meanwhile, the air war continued. Every day, Soviet and American fighters fought to the death over the MiG-Alli. The loss ratio did not change in favor of the Soviet side. The Americans claimed fantastic figures: 10 downed MiGs, for one lost Sabre. This is a clear exaggeration, classic propaganda. In reality, the ratio was much more modest. But even the real numbers showed that the Americans had gained some kind of advantage. The Soviet pilots begin to notice another strange detail. Before the Sabre opens accurate fire, a characteristic signal appears in the headphones. A thin, high-frequency squeak. Some experienced pilots have learned to react to this sound. As soon as they hear it, they immediately begin an evasive maneuver. And it saves their lives. Because a fraction of a second after the signal appears, tracers appear in the air, going exactly to where the Soviet fighter had just been. What kind of signal is that? Where does it come from? Some suggest that this is related to radar. Soviet aviation is aware of the existence of radar stations. They're used to detect aerial targets from the ground. But can a radar be mounted on a fighter jet? The technology seems too complicated, too heavy to fit on a small aircraft. On October 6th, 1951, an event occurs that will turn the whole understanding of the situation upside down. A young American pilot, Second Lieutenant Bill Garrett, leads his Sabre on a combat mission. Somewhere in the Yalu River area, he is intercepted by a pair of MiGs. A battle ensues. One of the MiGs, flown by a Soviet pilot, although Garrett does not know this, ends up in an American fighter jet. The shells pierce the fuselage behind the cockpit, damaging the engine and ejection seat. Garrett knows he won't last long. His car is losing altitude, and the engine is running intermittently. He's trying to make it to the Yellow Sea, where there is a chance to leave the plane and be picked up by a rescue helicopter. But another moment, he notices the damaged Sabre. The Soviet pilot understands that this is a chance to capture an American fighter jet, to carry out the order of Comrade Stalin. Instead of finishing off the American, the Soviet pilot begins to maneuver next to him, trying to drive the damaged Sabre in the right direction. Garrett struggles desperately, but his car can barely stay in the air. The moment circles around like a wolf around a wounded victim. Finally, the American pilot realizes that he will not reach the sea. As the Earth approaches, the engine starts to fail. It is impossible to eject. The chair is damaged. At the last moment, Garrett makes an emergency landing on his belly. The plane glides along the ground, raising clouds of dust, loses wings, turns over. When it stops, the pilot is alive but seriously injured. Soviet soldiers quickly surround the crash site. The American is dragged out of the cockpit and sent to a prisoner of war camp, and the Sabre itself is carefully disassembled and prepared for transportation. It was a real success for Soviet intelligence. Now, they have almost an entire American fighter in their hands. True, it was damaged, but the main systems remained intact. And the most important thing is that the sighting equipment has been preserved. The Sabre is delivered to Moscow in the strictest secrecy. The plane is taken apart. Every detail is photographed, measured, and schematized. A group of the best Soviet engineers is tasked with finding out all the secrets of the American machine. Among them is Senior Lieutenant Vadim Matskovich, an aviation equipment specialist. When Matskovich first sees the Sabre aiming system, he realizes that they have found the answer. A small radar unit is located in the nose of the American fighter, above the air intake. This is the APG-30, a radar rangefinder developed by General Electric. The device is quite small, but its value is huge. A Soviet engineer begins to study the system, and the more he learns, the clearer it becomes why the Americans gained an advantage in the air. It's not just a radar. It's a whole complex, revolutionary fire control system. How does it work? In a traditional site, such as the Soviet AS-1, the pilot must manually estimate the distance to the target. It's incredibly difficult. Planes travel at speeds under 1,000 kilometers per hour. The distances change every second. The pilot must take into account the speed of the target, the direction of its movement, its own speed, the trajectory of the bullets, the wind, and altitude. All this needs to be calculated in a split second while the target is in the firing zone. Even experienced aces make mistakes. Underestimate the distance and open fire too early. The bullets will pass ahead of the target. Overestimate. You will open fire too late. You will not have time to hit the enemy. A distance error of 100 to 200 meters at such speeds means a miss. The American APG-30 system solves this problem radically. The radar in the nose of the aircraft constantly emits a forward signal. When a target appears ahead, an enemy aircraft, the radio waves bounce off it and return back. By the time the signal travels back and forth, the system automatically calculates the exact distance to the target. The measurement accuracy is up to several meters. But this is just the beginning. The distance is transmitted to the computing unit of the A1CM site. This unit is connected to gyroscopes that measure all the parameters of the fighter's movement itself, roll, pitch, and turning speed. The system knows how your plane is moving. She knows how far away the target is. She knows the ballistic characteristics of machine guns, the initial velocity of the bullet, the drop of its trajectory. And the most important thing is that the system automatically calculates the lead point, the place in space where you need to aim for the bullets to meet the target. The pilot doesn't need to count anything. He doesn't need to guess the distance. He simply points the glowing dot of the sight at the enemy plane and presses the trigger. Everything else is done by electronics. The effective range of fire increases significantly. If Soviet pilots rarely open fire beyond 500 or 600 meters, then Americans with APG-30 can hit targets at a distance of up to 1,000 meters, and sometimes more. This is a huge advantage. This means that the Sabre opens fire first. This means that he has more time to attack. This means that the pilot can focus on piloting rather than on complex calculations. Matskovich makes a detailed report. His conclusions are unequivocal. The American sighting system is superior to the Soviet one in all respects. The MiG-15 can be faster, taller, and more maneuverable, but in real air combat this advantage is offset by the technical lag of the sighting equipment. The report ends up on the top management's desk. The reaction was unexpected and violent. In the Stalinist Soviet Union, it is dangerous to acknowledge the superiority of American technology. This can be interpreted as criticism of the decisions of the party and the government, as doubt about the correctness of the chosen course. Matskovich's colleagues write about 30 denunciations against him. He is accused of worshiping the West, underestimating Soviet engineering, and being defeatist. Matskovich understands that he is on the verge. He may be expelled from the ranks of engineers, sent to Siberia, or even worse. In Stalin's time, a person's career and life could end because of one careless word. But the engineer doesn't back down. He knows he's right. He knows that he has found the key to the Americans' advantage, and he has to find a solution. Matskovich is feverishly working to create a counteraction to the American radar. The idea comes unexpectedly. If the APG-30 system emits a radio signal, then this signal can be detected. Just as modern detectors detect police radars on the roads, it is possible to create a warning system for Soviet fighter jets. The development is in full swing. A simple receiver is being created, tuned to the frequency of the American radar. This receiver is installed in the tail section of the MiG. When a Sabre aims its scope at a Soviet fighter jet, radio waves are reflected from a MiG, and some of this radiation is picked up by the receiver. The system sends a characteristic sound signal into the pilot's headphones, the same squeak that Soviet pilots had already heard in battle, but did not understand its meaning. Now, this signal becomes a warning. When the pilot hears it, he knows that a Sabre is aimed at him, and fire will follow in seconds. He has precious time to start an evasive maneuver. This does not solve the problem completely. The Americans still have the advantage in the range of accurate fire, but it gives Soviet pilots a chance. The warning system is quickly installed on all MiGs in Korea. Soviet pilots receive instructions to immediately change course and begin vigorous maneuvering when the signal appears. This makes the task more difficult for the Americans. Now their precise aim is aimed at a moving, unpredictably maneuvering target. But this is only a half measure. The present solution requires the creation of its own radar sighting system. Soviet designers understand this. Work begins on the Soviet equivalent of the APG-30. But it's a difficult task. Radar technology in the Soviet Union lags behind the American one. The miniaturization of electronics is at an early stage. It takes time and resources to create a compact, reliable radar unit that can be placed on a fighter jet. Meanwhile, the Korean War continues. The Soviet Union is changing tactics. Instead of veterans of the Great Patriotic War, young pilots with minimal experience are being sent to the front. This decision is dictated by politics. You cannot risk the best aces. But this decision turns out to be disastrous. Young pilots cannot stand up to experienced American pilots, many of whom went through World War II themselves. The loss ratio is deteriorating dramatically. The Americans are beginning to claim fantastic victories. 10-1, 15-1. These figures are greatly exaggerated. American pilots, like everyone else in the world, tend to overstate their results. Several fighters can simultaneously claim the destruction of the same MiG. Debris cannot always be found for confirmation. In the heat of battle, it's easy to mistake a damaged plane for a down one. The real figures of losses will be established much later, when Russian archives will be opened after the collapse of the Soviet Union. According to Soviet documents, 335 MiGs piloted by Soviet pilots were lost in Korea for all reasons: in air battles, from anti-aircraft fire, in accidents. The Chinese lost 224 MiGs. North Korea's losses are not exactly known, but are estimated at about 100 vehicles, about 660 MiGs in total. American losses were 224 Sabres, of which about 100 were shot down in air battles. The actual loss ratio turns out to be about 2-1 or even 1.5-1 in favor of the Americans. This is far from the stated 10-1, but it still shows the superiority of Sabres. And a significant part of this superiority is explained precisely by the APG-30 system. The history of the APG-30 radar sight is the history of the technological confrontation between the two superpowers. This is an indicator of how one small detail, one system, can change the balance of power in an air war. The MiG-15 was an outstanding aircraft. Many American pilots admitted that it was superior to the Sabre in terms of pure flight characteristics. But technology turned out to be more important than pure performance. Soviet designers learned an important lesson from the Korean experience. The next generation of Soviet fighters, MiG-17, MiG-19, MiG-21, will receive significantly more advanced fire control systems. The Soviet Union will begin to invest huge resources in the development of aviation electronics, radars, and guidance systems. But in Korea, it came too late. By the end of the war, the Americans completely dominated the skies over MiG-Alli. North Korean and Chinese pilots who flew MiGs after the departure of Soviet veterans suffered heavy losses. Many of them were yesterday's peasants who had received minimal training. They took to the air on superior machines, but they could not use their potential against professionals armed with advanced technology. Vadim Matskevich escaped repression, although his career stalled for a while. Too many in the military hierarchy were unhappy with his conclusions. It was politically dangerous to admit that the Americans had surpassed Soviet technology in some ways. But the facts remained facts. And over time, when passion subsided, Matkevich's work gained recognition. His research formed the basis for the development of next-generation Soviet aviation radars. American pilot Bill Garrett, whose Sabre was captured and revealed the secret of the APG-30 system, spent 2 years in a prisoner of war camp. He was released only after the signing of the armistice in July 1953. When he returned home, he learned that he had become an unwitting hero of Soviet intelligence. His aircraft allowed the Soviet Union to understand the technology that gave the Americans an advantage in the air. The F-86 Sabre aircraft itself became a legend of the Cold War. It was the first American jet fighter capable of fighting on equal terms with the Soviet MiGs. In total, almost 10,000 Sabres of all modifications were built. The aircraft was in service not only with the United States, but also with many other countries. He has participated in conflicts all over the world, and wherever the Sabre with the APG-30 system appeared, it showed its superiority. Interestingly, the APG-30 radar sight system itself did not appear immediately. The first Sabres, which arrived in Korea in December 1950, were equipped with conventional gyroscopic sights similar to the Soviet ones. And in the first months of the war, the loss ratio was about the same. MiGs were shooting down Sabres, Sabres were shooting down MiGs. The pilot's professionalism played a crucial role. But already in the spring of the 51st year, modifications of the Sabre with the installed APG-30 system began to arrive. And it was from that moment on that the balance began to change. American pilots quickly evaluated the new system. It not only increased the accuracy of the fire, but also reduced the load on the pilot. In intense aerial combat, when the seconds count, the ability not to think about calculating lead, but to focus on maneuvering is a huge advantage. One of the American aces of the Korean War, Captain Joseph McConnell, who shot down 16 MiGs and became the most productive pilot of the war, later recalled that the APG-30 system was a decisive factor in his success. He said that even during sudden maneuvers, when the plane shakes, when gravitational overloads put pressure on the body, the system continued to accurately calculate the lead point. All the pilot had to do was hold the target in his sights and pull the trigger. Soviet pilots also quickly noticed the difference between early and late versions of Sabres. They learned to distinguish them by their appearance. Later versions had a characteristic radio-transparent fairing above the air intake, which housed a radar antenna. Seeing such a Sabre, the Soviet pilots knew that they were dealing with a dangerous enemy. The developers of the APG-30 system from General Electric could hardly have imagined the impact their invention would have on the outcome of the Korean Air War. For them, it was just another development, one of many projects to improve aviation equipment. But their work changed the nature of aerial combat and laid the foundation for all subsequent fire control systems. After the Korean War, the development of radar sights began at a rapid pace. They're systems with a longer range, with the ability to track multiple targets, with the integration of missile weapons. By the end of the 50s, fighter jets had radars capable of detecting targets at a distance of tens of kilometers and aiming air-to-air missiles at them. The Soviet Union did not stay away from this race. Moreover, having received detailed information about the APG-30 system, the Soviet designers were able to accelerate their own developments. The MiG-19 has already received a radar rangefinder, although more primitive than the American one. And the MiG-21 was equipped with a full-fledged radar capable not only of measuring the distance, but also of tracking the target. It is characteristic that the Soviet radar radiation warning system, developed by Matskovich as a response to the APG-30, became a progenitor of a whole class of systems. Modern fighters carry sophisticated radar exposure warning systems that can not only detect the fact of exposure, but also determine the type of radar, the direction to the signal source, and assess the degree of threat. The Korean War has become a testing ground for jet aircraft. Before that, jet planes existed only in theory and on paper. The Second World War ended at a time when jet aircraft were just beginning to appear. The German Messerschmitt Me-262 and the British Gloucester Meteor did not have time to influence the outcome of the war. Korea has become the first real test for jet fighters. And this test showed that the future of air warfare belongs to technology. It is no longer enough to have just a fast and maneuverable aircraft. Complex electronic systems, radars, and fire control computers are needed. The pilot remains an essential element, but he must be armed with advanced technology. This arms race continues today. Modern fighter jets are flying computers packed with electronics. Modern aircraft radars can detect targets hundreds of kilometers away. Fire control systems are capable of simultaneously tracking dozens of targets. Missiles are guided not only by radar, but also by infrared radiation, visual images, and GPS coordinates. But it all started with a simple idea: to measure the distance to the target using radar and automatically calculate the lead point. This idea, embodied in the APG-30 system, changed air warfare forever. The story of the confrontation between the MiG-15 and the F-86 Sabre in the skies of Korea is not just the story of two aircraft. This is the story of the technological race, the story of intelligence and counterintelligence, the story of the courage of pilots on both sides. Soviet pilots who flew without identification marks, who did not officially exist, died far from their homeland. American pilots risked their lives defending an unknown country from communist aggression. Both sides showed heroism. Both sides have shown the highest professionalism. But in the end, technology won. The APG-30 system gave the Americans the decisive advantage that the Soviet pilots lacked. After the end of the Korean War, thousands of veterans returned home. Soviet pilots received orders and medals at private ceremonies. Their exploits were classified for decades. It was only after the collapse of the Soviet Union that the world learned that not only Chinese and North Korean pilots fought in the Korean skies, but also Soviet aces, Stalin's best pilots. The American pilots returned as heroes. Their photos were published in newspapers. They were invited to television. They became symbols of American military might, proof of the superiority of the free world over communism. And although the reality was more complicated than propaganda, their contribution to the victory over the communists in the Korean sky was undeniable. The engineers who created the APG-30 system have never become celebrities. Their names remained known only to a narrow circle of specialists. But their work saved the lives of hundreds of American pilots and helped win the air war over Korea. Vadim Matskovich continued his work in the Soviet aviation industry. His study of the captured Sabre became a classic aviation intelligence work. He participated in the development of warning systems and radar equipment for the next generations of Soviet fighters. His career has proved that even under a totalitarian regime, honest professionalism and scientific integrity can overcome the political conjuncture. Bill Garrett's captured Sabre was sent to the Aviation Museum after careful examination. He still stands there today, a silent witness to the technological confrontation of the Cold War. Museum visitors can see the distinctive fairing above the air intake, the location where the legendary APG-30 system was located. Modern fighters have gone far ahead compared to the Sabre and MiG-15. But the principles laid down in that first radar fire control system remain relevant. Automatic preemption calculation, radar distance measurement, integration of sensors and guidance systems. All this is the development of those ideas that were first applied on the F-86 Sabre. In a sense, every modern fighter jet carries a piece of the technological breakthrough that took place in the skies over Korea. Every missile, every radar, and every fire control system are descendants of that first APG-30 system. The history of this confrontation teaches us an important lesson. Bravery and professionalism are not enough in modern warfare. We need technology, Innovation is needed. We need constant development, constant improvement. Anyone who stops developing, who is satisfied with what he has achieved, runs the risk of being defeated. The Soviet Union has learned this lesson. After Korea, the rapid development of Soviet military electronics, radars, and control systems began. Special design bureaus, institutes, and factories were established. The best minds of the country were thrown into solving the problem of technological lag. And within a few years, Soviet aviation reached a new level. The MiG-21, with its powerful radar and air-to-air missiles, could stand up to the best American fighters on equal terms. And later, MiG-23, MiG-25, Su-27 appeared, aircraft that were not inferior to their American counterparts in electronic stuffing. The Cold War turned into a technology race. Each side tried to outrun the other in developing new weapon systems. Radars became more powerful, missiles became more long-range, and control systems became more advanced. This race cost trillions of dollars in rubles. She forced the entire economy of both superpowers to strain. But in the end, it was this race, this technological challenge that led to the birth of many of the technologies that we use today. Microelectronics, computers, satellite communications, GPS, all these are byproducts of the military arms race during the Cold War. And it all started with a simple question that the Soviet pilots in Korea asked themselves: why do the Americans shoot so accurately? The answer to this question has changed the world of aviation forever. Today, more than 70 years later, in the era of drones and hypersonic missiles, in the era of artificial intelligence and quantum radars, the history of the APG-30 radar site may seem archaic. But this is not the case. The principles laid down in this system remain relevant. Automation, system integration, and pilot decision-making assistance are at the core of all modern combat systems. Young pilots who are boarding fifth-generation fighter aircraft today may not even know about the APG-30. But every time their onboard computer automatically calculates the aiming point, when the radar measures the distance to the target, when the fire control system aims a missile, they use technology whose pedigree leads directly to that first radar site that changed the outcome of the Korean Air War. The story of the confrontation in the sky over MiG-Alli is a reminder that in war, not only strength and courage win, but also intelligence, technology, and innovation. This is a lesson that is relevant today. In a world where technology is developing at a rapid pace, where every year brings new discoveries, military superiority depends on the ability to adapt quickly, learn quickly, and quickly implement new solutions. Soviet pilots in Korea encountered an unknown technology and at first did not find an answer. But they didn't give up. They hijacked an enemy plane, studied it, realized the secret, and began developing countermeasures. This is a model of professionalism and perseverance. American engineers created a system that gave their pilots a decisive advantage. They ventured to apply a new, untested technology in combat conditions. And this technology worked. This is a model of innovative thinking and risk-taking. Both sides showed the best qualities of their systems: perseverance and the ability to learn from the Soviets, innovation and technological leadership from the Americans. And it was this confrontation, this race, that pushed the development of aviation forward. Today, when we look at modern fighters with their sophisticated systems, it's hard to imagine that just 70 years ago, a pilot had to determine the distance to a target by eye and manually calculate preemption. It's hard to imagine that a simple automatic distance measurement system seemed like a revolutionary breakthrough. But that was exactly the path of progress, step by step, innovation by innovation. The story of the F-86 Sabres secret site is a story about how technology is changing the balance of power. This is a story about the courage of pilots on both sides of the conflict. This is a story about the perseverance of engineers and intelligence officers. This is a story about how the Cold War stimulated technological progress. And this is a story that continues today in every modern fighter carrying the legacy of that first radar fire control system. The sky over Korea has been silent for a long time. There are no more aerial battles, no exploding shells, no downed fighters falling. But the memory of those events lives on. He lives in museums where there are Sabres and MiGs. He lives in textbooks on the history of aviation. He lives in the hearts of veterans who are getting fewer every year. And he lives in technologies that were born out of that confrontation and still serve us today.